Hey guys, we're going to do a quick topic on something called spontaneous reactions and entropy. So a spontaneous reaction is one that proceeds on its own without any outside intervention once the reaction gets started. So that doesn't mean that it's happening fast or instantaneous when I say a spontaneous reaction. It just means that it can occur on its own under certain or specific conditions. So in order for a reaction to be spontaneous, there has to be a balance between two factors. It's going to be more likely to be spontaneous if it moves towards a lower, more stable energy state, and then if it moves towards increasing randomness or disorder. So energy, we've been talking about this unit quite a bit already, where we're talking about enthalpy or energy. Like I said, systems tend to move from higher to lower energy states, so exothermic reactions are more favorable towards a spontaneous process. So that's one big thing, is exothermic reactions achieve that lower energy state where it's more likely to be spontaneous. The other big factor is a new topic, which is entropy. So entropy is the disorder factor. We use a capital S for entropy. So entropy is a measure of the disorder, the randomness, the messiness of the system. I think the classic example that a lot of chemistry teachers use is think of your bedroom. If you do not put any effort or energy into your room, over the course of the week, it is going to slowly become messier and messier as you go. Or if I have 52, cards in my hand and I throw them into the air, what's the chance that they all land in a nice neat pile? They don't. They spread out. They become even more messy than the cards that I'm holding. So nature actually favors reactions that undergo an increase in entropy. So the greater the disorder, the greater the randomness or messiness, the higher the entropy. And systems in nature are going to move towards a state of a higher disorder or randomness. So greater entropy. So you're going to have to be able to look at a question and know, is entropy increasing or decreasing? So the first thing you are going to look for are phases. You're looking at the phases of your reactants and your products. So solid has the least entropy. Think about phases. Solid are in nice, neat, organized rows if it's in a crystal lattice. When it goes into a liquid state, they're still close together, but there's more disorder. They're randomly spaced, they're able to flow around each other. A gas, they're completely separate and they're moving all over the place in the container. So solid has the lowest entropy because it has the most order. Then a liquid becomes a greater entropy. Once you mix like a solid or a liquid into water, an aqueous solution, that has an increase in entropy, and then gases have the highest entropy. So always start with phases first. If, say, they're all gases, then you're going to look at first how many reactants or products are on each side, and then the second thing is going to be temperature. So if you had nothing else to base it on, you would look at temperature. The higher the temperature, the more random the motion of the particles. So this would mean the greater the entropy. Entropy. So one thing you have to know from this video is what entropy is, that measure of disorder. Knowing how to pick out when entropy is increasing or decreasing, either based on phase, the number of molecules on each side, or the temperature. And the other part is this idea of going back to a spontaneous reaction. So how does this all move into whether a reaction will be spontaneous or not? Well, a reaction will be spontaneous if it creates a lower enthalpy or energy, your exothermic reactions, and if you have a higher disorder or entropy. So you'll usually see reactions in nature tend to be spontaneous or move towards systems with, you're always going to look for lower enthalpy and higher entropy. A way that usually we have you guys remember this is to think about it's easiest in life if you're not going to do anything to be lazy and messy. People will move towards that if they don't put in the extra energy or effort as they go. Lazy part stands for the low energy. Messy stands for the high disorder or the high entropy. So watch the other video I post, and then you guys will be all set.